All right, we're back with another Ohio State test review, standard review. Yes. All right, today we're looking at standard 8.SP.1. This one mainly has to do with scatter plot graphs. So let's hop right in. The graph below shows a relationship between the number of computers sold and the number of printers sold at different electronic stores in a city. What type of association best describes the relationship between the number of computers sold and the number of printers sold? So when you look at scatter plots, you're looking at three different types of relations. Okay, you're looking at positive relations, you're looking at negative relations, and you're looking at no relation. A positive relation kind of looks a bit like a linear equation that has a positive slope, meaning it's trending upward. Okay? A negative relation would be, again, kind of looks like a linear equation, but this one is trending downward. No relation is kind of just all over the place, no rhyme or reason to where the dots go. There's no correlation, there's nothing. Okay? So, when we look at this first graph, we have to ask ourselves, what kind of relation is it? Well, does it look like it could suitably be modeled by a linear function? And the answer says yes. You look like you could probably draw a line kind of like this, and it would be a linear function, and it would kind of fit. Okay? And it is trending upward, so it would be a positive linear association. So we go down to the next one. A scatter plot is shown. What statement about the scatter plot is true? So again, we're going to look at this. Could this be represented by a linear function? And you look at this, and I would say yeah. You could reasonably argue that that's a linear function. So now it's all about, is it positive or negative? Well, the line is trending downward. As you go more to the right, you're getting closer to the x-axis. So this would be a negative linear association. Okay? And that's actually it for this standard. You know what? You're actually going to get a twofer. You're going to get 8.SP.2 here as well, because I believe that is only one question. So let's look at this one. A linear model is drawn on a scatter plot as shown. Which statement best describes how the linear model fits the data on the scatter plot? All right, so what they're drawing here with this linear model, it's called a line of best fit. Okay? And what the line of best fit is meant to do is it's meant to be a predictor. Okay? So you can look on here. I don't really have a data point for where x is 75, right? Which would be right here. Okay? The line of best fit is there to predict that if you had a data point at 75, it would be somewhere around here, which would be y equals 5. Okay? Is it perfect? No. It's not perfect. The goal with the line of best fit, even going up to the previous one, like what I did, here's a good example of a line of best fit. The goal is to get a line that goes between your points, almost like an average, right? You want about half of the points above the line, and you want about half of the points below the line. So here we have 1, 2, 3, 4, 5, 6, 7, 8 points above the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points below the line, which isn't a perfect split, but it serves its purpose, right? It's about a 50-50 split. That's when you have a good line of best fit. If we go back to this question, is this a good line of best fit? Well, let's look. We have how many points above the line? 0. How many points below the line? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is 0 and 11 an almost 50-50 split? No, not even close. This is literally 0. So this would be a bad line of best fit. Why? Because too many data points are below the line. That's it. It's a bad fit because there's too many points below the line. If you wanted an actual good line of best fit, your line of best fit for this one probably looks... no, maybe not that. Probably starts about 65 and trends down this way. This is probably what your line of best fit looks like. I'll put it in a different color so that you can see it easier. The red line is probably what your line of best fit looks like. There you have 1, 2, 3, 4, 5, 6 points above, and you have 1, 2, 3, 4, 5, 6, 7 points below. That's as good of a 50-50 split as you can get. That's a better line of best fit. Okay. So, and that's already going to do it for this lesson. You got a twofer. You got a twofer out of this one. 2 standards in 6 minutes. So, yeah, I'll be back with another standard soon. Until then, good luck on your state test.